Okay guys, so a lot has happened since the last video. A lot of good earned money was spent. We can't ignore it, we have to program something. Luckily my brother will help me with this, and for this video today we will focus on again machining and moving the joints 1 to 4 with a PlayStation controller. So that's a big goal. Hope you enjoy this video. The first prototype used an Arduino for control. Later we switched to a Teensy board and had to solder it first. The robot stuttered because the baud rate of the serial connection to the PlayStation controller was too low, but we quickly got the first 4 axes moving.
That's cool, ne?
After some tweaking, the Teensy was running smoothly. And then finally we organized the wiring and connectors to keep everything clean. I then wasted 30 minutes of my life preparing limit switches that we wouldn't use. The connection between the arm and the output shaft of the gear needed a complete redesign because it was just too weak, so I added these dowel pins. We also ramped up the diameter of some bearings. We have some new tools, longer ones especially, because I thought maybe it's unnecessary to mill the motor plate and the housing separate. So I joined these two parts in the design and will mill them from 25mm of aluminum. That's why I decided to go with an 8mm end mill, 2 flute. So we will try that out for sure and see you there. I then used 3D printed precision and a high-tech vise to press in the pins. First one worked good, but then I quickly messed up. So yeah, not a good idea. But with the power of editing, there comes a new one right here. Again, a short tolerance check before we continue with the second operation. We have assembled the arm of joint 1 completely, so it consists of 2 plates, one like this, one like this. And the basic concept is you have 1 ring bearing which keeps the radial forces, and then 2 needle bearings which are for the axial forces. The torque will be transferred by these dowel pins right here, so they are pressed into the output shaft of the gear. This arm is attached here. So what I will now do is basically take this joint apart again to align these two edges. I will use this angle here to reference this edge, and then I will put the whole arm down on a very flat surface, and then I will tighten these screws. By the way, here you can see the old connection. These nuts right here, they are to adjust the play of the axial needle bearings, and what they are doing is they keep everything together. So at first I chose an M8 down here, but in the future I will use M10 for this one. Because we don't have absolute encoders, or at the moment we have no encoders, we need to home the robot, and for this we have these inductive sensors. And for joint 2, so this one, it will home right here. This one is attached to arm 2, so the big one. And yeah, now we will machine this one. I only had one aluminum stock for this part of the robot, so there was no room for mistakes. I was super nervous and double checked everything. The setup and C program, work holding, probably 1,000 times. So I just couldn't afford a failure. If I mess this up, it will probably cost me another week. I will use a new end mill. It's an 8mm single flute, and now we just need to measure the tool length, and then I hope to get a really fast and great slotting around the part. I was shaking the whole time. I was pretty nervous with this part. However, now that the first operation is done, I'm so blown away by the quality of the new tools, the 8mm tools, and the fit. It's all perfect. So for my machine, these holes right here, they fit so nicely with the dowel pins. Time for the second op. And that's it for today. Milling this industrial robot is a challenge. I hope you enjoy it. If you want to see more of the robot, let me know with a like. I will make sure to film it, so thanks for watching and see you in the next video.